plenty of time for a robust question and answer session following the presentation. So I'm going to keep an eye on our waiting room because we still have some people who are joining, but I'm going to go ahead and turn the presentation over to Vassar to kick us off, and then Stefan will take us home.
Great. So I think Jen's going to move that to the map of our campus so you can see all those who've never been here before. Because I don't actually have control of the screen. Thank you. So I just wanted to give you an overview of what Rosevilla is, what kind of community we are. We've been here since 1960, so not a newcomer, but we've been under evolution pretty much since I arrived in 2006. It took a while to understand what was needed on the campus, and we had the opportunity to think through what we could create on this really magnificent piece of property over the Willamette River if we could do anything we wanted to. And so we started really back in 2010, very seriously master planning the whole campus to think through what sort of neighborhoods, what was important to the community, what was not thought of back in 1960. And there's plenty of things that were not thought of back in 1960. So we've really been in evolution pretty hard since 2010. We started design and building in 2014. So we currently have about 9 neighborhoods, which includes the zero energy communities that we're going to be talking about today. But in our big rebuilding, which has really started in 2014, we started with our phase 1, which was to create North and South Main, which is the kind of the entrance to our whole campus off of River Road, and then a big swath of pocket cottages. And the identity of Rosevilla really is very outdoors oriented. So everyone here originally came here because they could have a front and a back door and all the windows that open, and great yards to play in and have dogs and barbecues and live your life. So that's a big deal for the folks who live here, and it sort of creates a community that self-selected people who really like to be outside. Nobody's afraid of getting wet when they get their mail, as an example. So phase 1 was our North and South Main buildings and a bunch of pocket cottages, about 75 new homes. Was followed by phase 2, which is the Oaks and North Pocket, the Creative Arts Building, and Garden Grove. And those are different. All of these neighborhoods look different, feel different. And there were 42 homes there. And then we have just embarked on phase 3, which are the Schroeder Street Lofts, our new Madrona Grove, which is a supportive 24-hour licensed care neighborhood, and Trillium Townhomes. So the things that we've built in the course of all of this, besides just those housing units, include, we have a couple of restaurants here, we have a library, we have really, it's very important to us, our fitness center. So we have a really awesome weight room, a yoga studio, a saline pool that includes a lazy river and a slide and a giant hot tub. All of those things are open 24/7 to residents in non-COVID times. COVID times were a little more restricted, but we hope to get back to non-COVID pretty soon. We have a performing arts center and a full service salon and spa, as well as a 2-acre community garden and all kinds of outdoor spaces, because we are really an outdoor focused community. So our goal is to build things with intention that satisfy not only the people that are here and have been here for decades. We have, all kinds of residents who live here, but also the people that will be coming in the future. So our phase 1 development broke ground in 2014. That was $60 million, and it was completed in 2 years. And it was brutal because it was really infrastructure, a bunch of really unsexy things as well. So the campus is very modern in its infrastructure in many, many ways. Phase 2 broke ground in early 2018 and was completed in 2019. And then the phase 1 that we're engaged in right now just broke ground in 2020, just last year, and we're scheduled for completion in spring of 2022. And we've already welcomed most of the new neighbors who'll be joining us in these homes. I think we only have 2 Trillium homes left. So looking at the Oaks, our next slide at Rosevilla, which is our first net zero energy development, the Oaks was kind of a big deal for us to do. It was a stretch because it had really advanced energy technology, and we weren't positive that something in a senior living community would attract the kind of interest that we needed for it to be successful. And we really hit it out of the park. It was the first neighborhood to sell out in phase 2. It includes 4 triplexes centered around this gorgeous heritage white oak. The courtyard includes a bunch of native plants and a bioswale. It's a very inviting, beautiful neighborhood. And it's a place that the folks who have, by and large, the folks who have chosen to live there are very committed to living their values. And this is one way that they are able to express them. So we felt that there was a big demand for more sustainable living, and that I really feel that elders in many, many ways are advanced scouts and sort of the moral arbiters in some respects, because they have a better perspective on what's important. So that's one of the reasons why the Oaks, I felt, was really an important statement for us to make. And I was very anxious to see if I was right and about the people that I felt would be drawn to it. And we've had an incredible community gather and live in the Oaks. It's been really cool to see those neighbors coalesce and make that neighborhood a real place. So the other thing that's really awesome is that it's not just theory. So we now have been in operation long enough that we've gotten the results from the energy generation, solar panels, and the energy usage. And we are indeed net zero. So the goal has been met, and we're currently tracking as a net positive community, because it does look as if we are producing a little bit more than we thought and using a little bit less. So this next year, with more robust controls in place and an ability to look at all how the machinery is functioning, should give us a lot more information. So that brings us to our desire to build another net zero neighborhood. So the Oaks was really successful. It made me feel that there's a high demand for homes that allow people to live with a low carbon footprint. And I really like working with Green Hammer. So as we started thinking about phase 3, it was like, well, where can we put the net zero neighborhood here? How can we make that part of what phase 3 is going to be? And so we came up with Trillium Townhomes. So that's a net energy community of 6-row homes. And we want every neighborhood to feel and look different. So the idea around this was, we kept thinking, well, what about like a row house of industrial homes from an older city? Obviously this is all new construction, but we want it to look and feel and have some character. And so that was the idea behind that. So today we're going to talk a little bit about how you live in a zero energy home. What does that mean for you? It's not like buying a new car. It's a lifestyle decision. So it's a big deal. And we'll talk about some of the unique attributes of Trillium Townhomes. And I'm gonna, Stefan really knows all you can know about the technology and how these things are designed. So I'm thrilled to hear the presentation. I'm gonna turn it over to him.
Stefan, you should be able to unmute yourself.
All right. Okay, can you hear me now?
We can.
All right.
Signal.
Thank you. Sorry, there was some weird setting there that took care of. So why zero energy? I think there's a lot of reasons why. We certainly aren't going to cover all of them right here, right now. But for Rose Villa and for Green Hammer, I think there's responsibility to create eco-conscious housing for a few reasons. Not the least of which is that we kind of knowledge is power, and we know how. And now we see that there's a real demand. So we owe people living options that match their values. And so now that we know how to do this and we have some success behind us, we really want to try and create more opportunities. And the Oaks was very much an innovative new project. It really wasn't a senior living. We haven't found any sort of senior living options in the United States that are meeting zero energy. It doesn't mean they don't exist. We're not aware of any in the industry. And so it really was kind of a brand new endeavor for everybody. So we kind of walked into a whole new space. And now that we know we can do it, we're really excited to be providing that, because everyone should be able to enjoy, cleaner air, comfort, and low energy bills, all of which are, aspects of being able to, when you're delivering zero energy buildings, there are aspects of the zero energy building that we're going to talk about here in just a minute. Zero energy buildings are also part of the solution for climate change. So carbon emissions in the built environment are around 40% of the entire kind of puzzle. And, you know, if we can, and homes are really about 20% of that. So if we can create zero energy homes, we're essentially offsetting that 20% impact just from the residential housing piece. So that's a huge step in the right direction when we're trying to address climate change. So we can move on from here. And so this next phase with Rose Villa and the Trillium. So we have the Trillium image of an interior on the left, and to our right, we're seeing kind of the solar panels at the Oaks. At the Oaks, we had a 73 kilowatt solar panel system that provides energy to the grid. And then it's also consuming energy from the grid on a regular day-to-day basis. So when the Oaks residents are, you know, using their buildings and using their cooking systems and heating and cooling systems, that's pulling energy from the electrical grid, and those solar panels are feeding energy to the grid. On an annual basis, we designed the project so that the solar panels could provide at least as much energy and a renewable energy as the buildings consume. So on a really sunny day, it's going to be sending excess energy to the grid. And on a really dark day or at night, it's going to be pulling energy from the grid. But the idea being that at the end of the year, when we kind of, you know, look at the full energy usage versus the full energy demand, that they equal, and so net zero. And the similar will be true at Trillium. We've designed that also to have what looks like right now is a 30 kilowatt solar panel system that will be doing the same thing. So again, it'll be providing energy to the grid when there's excess energy from the site, and it'll also be pulling energy from the grid whenever there's a shortage. And the goal being at the end of the year that we equal out net zero or potentially net positive. So we can move to the next slide. And so the way that we accomplish that is through what we call a passive house approach. It's actually a certified standard. It's a standard that came out of Germany in the 1990s. A group of physicists were really hired by the German government to come up with a way to make their future building code as energy efficient as possible and as least dependent on fossil fuels as possible. And so the passive house approach is really about reducing your energy demand in a building by about 70% and your heating and cooling loads by 90%. And so to do that, we kind of take these really basic approaches. The first being that we make them really airtight. We use energy efficient appliances and lighting. We super insulate the buildings, including triple pane windows, and then we put in a really advanced ventilation system. So I'll get into that as the details as we move forward. So next slide. So first is that the buildings have to be all electric. If we're really going to offset all of their energy use on site with renewable energy and solar panels, then the easiest way to do that is if the buildings are all electric. The other bonus to that is cooking in general creates a lot of toxics. And when you cook with natural gas, it can actually create even more. So the beauty is we actually eliminate some of those combustion systems from inside the home that add toxics to the air on a day-to-day basis. But also we create some new opportunities. One of the things that we do besides the LED lighting, which now is pretty prevalent, when we were doing even just the Oaks, which again was in design in 2017, there are more and more LED options coming on the market then, and now it's pretty much the market standard. So lots just changed in the past few years, pretty cool. But we use all Energy Star appliances. Everyone's probably familiar with that rating and standard, but generally speaking, Energy Star is always trying to be about 15 or 30% more efficient than whatever is on the market today. And then the market is always kind of moving toward the last Energy Star standard. So appliances are continuously getting more and more efficient for the past 40 years or so. One really cool advancement are induction cooktops. A lot of people are like, oh, well, but natural gas cooktops, yeah, they may not be great for air quality, but they're really awesome to cook with. And I totally get that. I love to cook. I may not be the best cook, but I love to cook. And we've had a lot of clients who are semi-professional chefs, frankly, in the past. And the cool thing about induction cooktops is it's a relatively new technology, but it's been around for about 40 plus years. And it was really innovated in the Japanese market. So in Japan in the 1970s, there was a goal to eliminate natural gas in these really tall buildings. But again, you have a really strong culinary culture. So, okay, electric resistance cooking is really slow and energy intensive, but in particular, it came from a concern around just the rapid ability to heat your food or cool down, as you're cooking, to lift the pot or whatever you need to do with natural gas and be able to turn it on and turn it down. Well, induction was basically a response to that. And what it does is it uses electromagnetic frequencies to take a ferrous pot. So your pots and pans now suddenly have to be metal-based, or iron-based rather. And so there is a transition there. But once you get all iron-based pots and pans, all it means is that a magnet can stick to it. Once you have that strong magnetic pot or pan, and most things now, again, with the oaks, when we were designing 2017, that was relatively new. And so it is still new today, but it's becoming less and less new, I think, for the US market. But again, in Japan, the idea is like, let's make this happen really fast. So the cool thing is your pot becomes the resistor instead of the electric resistor underneath the glass or in the coil on an electric standard electric range. And so you can heat and cool down really rapidly and very instantaneously. So you can boil, a pot of tea water, for instance, or a teapot in like 60 to 90 seconds, or like a big pot of spaghetti, pasta boil, for instance, in a few minutes. And it's actually faster than natural gas and has more responsiveness. Again, there's always some push and pull about what's the best there, but the beauty is that induction is a huge advancement from electric resistance. And so the units have all induction cooktops, and that helps again from air quality, but really what we're trying to do again is move to all electric and use the most advanced technologies. They use less energy because again, you're transferring the energy directly to the pot instead of through conduction from heating either the coil or the glass top and then transferring that through. The other big heat load that's pretty common in buildings, and it's a total advancement that was at the Oaks and will also be at Trillium, are these heat pump hot water heaters. And so heat pump hot water heaters are becoming more and more common. What is unique to both the Oaks and a few other Green Hammer projects and Trillium are these carbon dioxide refrigerant heat pumps. And in this case, it's called the Sanco. It's a Sandin CO2. It's a transcritical heat pump. It uses carbon dioxide as a refrigerant and essentially has about 2,000 times less global warming potential as a refrigerant than your standard heat pump does. And so we're really excited about that. They create super hot water and really high capacity. And so far, there's been some lessons learned for sure at the Oaks. It does seem that the hot water delivery system has been relatively successful, and we're pretty excited about that new technology and continuing that new technology forward. Okay, next slide. I should mention that the hot water system is also about 4 times more efficient than electric resistance and about 3 times more efficient than your most efficient natural gas. So 1 kilowatt of energy in on those Sandin heat pumps is 4 kilowatts of energy out. The rest happens through the magic of taking energy out of the air and the transcritical refrigerant cycle of CO2. We can talk about that if you guys have questions afterwards, but super insulated and airtight. So again, we'll talk about ventilation in just a minute, but to create a really efficient building, the biggest energy load is always your heating and cooling. And the best way to save energy is to really kind of, lock that system down. And so what we do is we use some advanced Swiss membrane systems, in this case, SIGA. And it's think of it as like a 5-layer Tyvek. You might have seen that. It's a weather barrier. And so it actually adds an extra level of weather protection to the buildings too. So it's a super weather barrier that gets taped with these really advanced tapes. And there may be also, we are using some self-adhered membrane now, which is their next generation weather barrier. It's been around for about 10 years, but we're starting to see that on our projects now too. That makes our nice airtight barrier, and then we super insulate. So we actually have thicker walls. So we're typically doing 2x8 walls instead of 2x6 walls to allow for a little extra insulation in the wall system. We typically do about 2 feet of insulation, and the Trillium will have this, 2 feet of insulation in the kind of attic or upper level layer versus what code would be closer to about 12 inches of insulation. So about double the standard there. And then we also add some exterior insulation to the walls. And in our case, we're using mineral wool. And that does a few things. It allows the wall system to dry out rapidly if there's ever any moisture intrusion. And it adds an extra fireproofing layer to the building and just essentially an extra durability layer. And the last thing we do is ventilate the entire cladding system on the building. So super insulated buildings just need a little extra care in the system because all of that insulation can also, be problematic if you don't ventilate both the insulation well and the interior environment. So we're going to move on. So one way we ventilate and we insulate is through these triple pane tilt turn windows. And so these are kind of super insulated windows. They're triple pane. They also have 5 points where they lock. So as you can see in this image, a resident is showing in a video that we'll see in a moment how these windows operate. And they tilt in for some nighttime or daytime ventilation, if you like. And they also turn and open all the way in. And so that can allow for a lot more ventilation or to clean the inside of the window. They're typically about an R value of 8 or 10. A standard window is going to be down at like 3. So you're about 3 times more energy efficient than a code window would be. And it's also much more comfortable, but they allow for some really effective and efficient ways to ventilate in also a secure way. So the tilt-in method, the window is open, but it's still very secure. So that's also another added benefit of these types of windows. Okay, moving on. So the unique thing about Trillium, it came from some lessons learned on the Oaks and some other projects. This system was around when we were doing the Oaks. It was brand new at the time. We've had it on some other projects and through some testing. And what it does, which is different than the Oaks and previous projects that had separate heating and cooling and ventilation systems, it actually combines them. And it has a slightly tighter filtration system than previous buildings, a little bit more controls about how ventilation can move through the building. But essentially what's happening is we're going to be taking outdoor air and continuously bringing that inside the building, and then continuously exhausting air from inside the building. So generally you're feeding fresh air to living areas and bedrooms, and you're constantly exhausting out of kitchens and bathrooms. And inside the system, we actually have a heat pump that is also adding energy or subtracting energy to adjust for comfort in the system. And there's some cool advancements about this. We can talk about it again in the Q&A, but it does allow for shutting off any outdoor air and just going through a recirc and recirc filtration mode. It's also smart in how it balances interior relative humidity. We have found that our buildings in general do a pretty good job of managing relative humidity and some of the other items on their own, just by having a super insulated building. But this system is just one notch smarter. And so we're pretty excited about it. And it's a really great opportunity for the Trillium residents and that project to kind of take this next step forward. But again, all of these buildings and zero energy buildings, one important component is that they ventilate on their own. And you can always ventilate with windows if you would like at any time, but the system's also ventilating on its own and managed for things like carbon dioxide, any type of volatile organic compounds that you might introduce into the space or may be in the space. Sometimes exterior components can get into your air quality. And so you want to make sure you're flushing the air as often as possible. Most indoor air environments, or most of us spend about 90% of our time inside. And the EPA rates that indoor air quality is about 2 to 5 times worse than outdoor air quality. So even if you're just tracking with outdoor air quality, you're about 200 to 500% cleaner than the average home. And so one way we do that is by continuously refreshing the air. But in this case, we're also able to add some filtration to the outdoor air. So we're often tracking a bit cleaner than outdoor air, which is a huge advancement for these types of buildings. Okay, moving on. All right. Okay, that I guess was it. That's the main components of your zero energy Trillium townhomes. I'm sure there's going to be a lot of questions, but we do have a short video that's going to come up in this next slide about Vassar telling you a little bit more about this project and me geeking out a bit as well.
I've just been informed that the volume's not playing for the group, playing on my end. I have it all the way turned up, so. Still no sound. I'm going to go ahead and send everybody the link to the video and we can watch it after the event. So in the meantime, you've all got permission and ability to unmute yourselves. And I encourage you to do so now and ask questions of our guests.
I have a question. Do you also want us to start video or anything? But may I ask a question?
Yes, absolutely.
Okay, all right. So thanks, Jennifer. So I have a question on these homes. Are the residents complaining about the lighting and whether or not it's sufficient? And about mold by chance? The tighter the construction, the higher the incidence of mold that we can have. And then also, is there any thought about having a battery for the home for when the electricity goes out the next time?
Yeah, I think I can answer a lot of these. There are a couple of residents that are here too. So maybe after I answer, if anyone wants to add something, I invite them to add to my my response. So there are you're absolutely right. So one of the reasons why we take a lot of additional measures when we're designing and building these buildings is to ensure that we prevent against things like mold. So when you super insulate a building, one of the things that was being discovered in the 60s and 70s when kind of super insulated original passive house buildings were being put together is that there's some confusion about where you put vapor barriers and the permeability of the building envelope systems. And so, I've spent most of my 20-year career, the 18 years with Green Hammer, kind of, deep entrenched in building science. Before I actually before I started Green Hammer, I was a mold remediator. I worked for Mold Puro first on the East Coast as a mold remediator. So I'm definitely hyper concerned about mold and how we manage for that. And so we do a variety of things. So one of the things that we do is all of our building envelopes are actually what we call vapor open. And so they are airtight, but vapor open. And we do design them actually to dry out to the exterior. And we use things like plywood instead of oriented strand board because it allows for increased permeability in the building envelope. And we also pay a lot of attention to the storage materials, the things that can store moisture in the building envelope. So we use a lot of cellulose insulation, which has a huge capacity to store moisture and also release it and dry out, so that if you do have an incidence where there's really high humidity, there's a tremendous amount of moisture storage capacity in these buildings and their building envelopes. In fact, just 1 cubic foot of cellulose is about 3.5 pounds of cellulose weight, and it can store about 1 pound of moisture before it actually gets what we call wet and be at the level where it could start growing mold. And when you add that 1 cubic foot over an entire building, we suddenly have hundreds and hundreds of gallons of moisture storage just in the wall systems. Well, we are monitoring a lot of our buildings, and I live in one, for relative humidity, in fact, volatile organic compounds, particulate matter, PM 2.5, a variety of things. And so, and mold. So mold just here really, but it's one of our zero energy projects. And what we're finding is really, really good results and some mixed results. With the wildfires last year, we found some concerning results around the ventilation systems. If they're on, they still get some bypass on your filters. And in particular, we found wildfire smoke is super, super small. And so there's bypass in those filters. So we have new emergency action plans we're starting to share with Rose Villa on those systems. And we have some new benefits to this new ventilation system too, and ways to manage the old ventilation, the other ventilation systems in those events. Light is a huge concern for us because health is one of our #1 goals as a company. And so light really impacts human health in a lot of ways. And so we look at lighting in a few ways. And one is, where windows sit on wall systems and how high. One thing you might have noticed in the early rendering image that you saw.
Stephen,
Yep.
sorry, your stuff is fantastic. And I'm sorry to interrupt. This is a terrible tendency.
Yeah.
But I'm wondering if people might want to hear also from residents about this. So when you're done, just be mindful that some of us can respond also. So thanks.
Okay. Yep. So I guess anyway, so from a lighting standpoint, one of the things that we do is push windows up on the wall systems. And so that allows more light to come down cascading into space, if that makes sense. And we also, when we look at the LED lighting, for instance, we're paying a lot of attention to the color rendering index and trying to get as high CRI as we possibly can. And so it best matches an incandescent bulb. And similarly, we're trying to look for a low Kelvin. So something down in the 2700, 2800 range to best match, what you would expect from an incandescent light bulb as well. And so, again, I would be interested to hear from the Oaks residents about how lighting was for them. Trillium does have an advantage in that there are some nice high clerestory windows from a lighting standpoint. That wasn't really an opportunity in the architecture at the Oaks. Anyhow, just wanted to review all of those things. So I think I'm done.
I think I can speak really quickly. I'm a resident in the Oaks. My name is Kathy. Wanted to say that we've been here almost 2 years now. No mold, ever. The lighting, also, I'm a retired architect and worked for a long time in the green building sector. So I was very interested in moving into these units in order to actually get to live in a unit that was similar to something I had had a hand in. The daylighting is fabulous. And so much of the time during the day, we don't need to use the lighting at all. I've been a little worried about that because I place windows a little differently than they are in this unit, but it's really, really lovely. And the LED lighting works really well. Again, I never lived under LED lighting. I just specified it. And it's really been fabulous. It takes a little bit to get used to the windows. The doors especially, you worry a little bit about they're gonna fall on you, which they're not. But once you learn how to operate them, you add to your own ability to ventilate the homes. So, and I'm happy to provide my email or phone number to anyone who wants to ask questions directly.
Thank you, Kathy. Sorry, I forgot one bit was the battery. I don't believe we're doing batteries on this project either. And I forgot to verify that before. There's a few reasons we didn't do it on the Oaks. One is battery technology, even in the past 3 or 4 years, has advanced tremendously. And we're seeing actually in our industry in general, most of the advancements are happening with this mechanical systems and with especially solar systems. Panels a little less so, but much more with batteries. And there's a few things to think about. Rose Villa is a pretty large campus. And when there is a power outage, there's a process that they're going through to manage with generator backup energy power. And I do know that eventually there's going to be some transition to what they're doing now to where they're going to be 10 years from now. But right now, it makes the most sense to manage, that campus from a really consistent standpoint. And, systems are changing in general. So there will be natural change in how emergency action plans evolve over time. But really right now, to simplify everything, we want to have the same kind of emergency action plan for the Oaks or for Trillium that we would have anywhere else. And if and when batteries really kind of feel like they're going to be a secure system for Rose Villa, those two communities, of course, are the best set up to be adaptive to batteries. And so we have set up a system so they can easily add batteries, but I don't believe they're going to have batteries out of the gate.
And I'll just say very, very quickly, happy to talk about emergency experiences anytime, since we've had the fabulous good fortune to have a great run of several days with no power. So we are pretty confident in our ability to take care of everything on campus, but every emergency is going to be different. So I will say the one thing that's really, really clear is that the net zero homes hold their temp. So there's really, you've got a lot more runway before there's a problem inside your own home. This particular emergency, the Oaks never lost power. I think there's at the very end there's a loss of power, but even our other newer constructed buildings are so well insulated that they're holding temp so much better than my old house did. Thanks.
Hello, I'm Bob Sack and my wife Corinna, and we are going to be moving into Trillium. And we have just a couple of quick questions. One of them, we're working on furniture arrangements, and we were wondering what the dimension is between the floor and the sill on the windows. In other words, how high up are they, so we can plan on furniture underneath. And we were also kind of wondering if you could explain how the storage under the stairs will work. Would you be able to comment on those things?
I don't have that exact answer. I suspect we're probably close to. I don't even want to speculate actually, because we don't have the architects from my team on the call, and they would know that much more precisely. So I think we'll get back to you on that answer. And sorry, then what was the second part of the question again?
Well, the storage under the stairs, how will you access it, and what will it involve?
That would be a good question for them too. I believe there's a door, but yeah.
Yeah, I know she's on the call and she's taking all these notes down. And so we're going to have meetings as we did with every other neighborhood that's moved in. We'll have meetings with just the residents of those neighborhoods, the people that are planning on moving in, to get really detailed so that you'll have all of those measurements and you'll have all the answers to the questions for where you're going to live. So no worries. This is more of an overview of net zero and how does it work.
Thank you.
But great questions.
I have a question. This is Gila. Can you hear me?
Yes.
We
Okay.
can.
Thank you. I appreciated the answer about the lighting during the day. I'm more concerned, I have a special concern about the lighting in the evening because I'm getting younger, as we all are, and my eyes need more light for things like reading, and need it close by. So maybe one of the residents could address how the lighting is at night. The LED.
My name's Ed. I'm a resident of the Oaks with my wife, Jean. And as far as the LED lighting goes, I think it's excellent. I have no problem at all reading at night. Most of the lighting is on a dimmer switch, which is very nice. So you can dim it if you want to have slightly diffuse lighting, or you can bring it all the way up to the top, and it's very bright. Our custom is kind of towards minimalism, and so we don't use table lamps, and we just primarily just use the ceiling lighting, and it's worked great. I think it's fantastic, and my wife loves the under counter lighting. It's a little luxury that we've never had in our life before, and so we really appreciate that.
Thank you.
So I was going to speak to the lighting. I'm a person who likes the super high level of artificial light. In fact, it's a little bit of a conflict in my marriage, but we opted for we had an option in the living room and in the guest bedroom to add a ceiling fan, which I would really recommend if you have that as an option. And it has a light in it. And so that allows me to boost the light in the living room and in the guest room. It was already coming in the master bedroom. And so if you want, it is one way you can bring in more artificial lighting without having to use a lamp. That's the other way. And so we do have lamps for reading strategically placed. And I think if you really need more light, you might have to do that.
Thank you.
Yep. So that's great. And I don't know that I have much to add other than what was relatively stated, except when we're designing these buildings, we really are thinking about the full lighting. So, trying to come up with a full lighting plan so that you don't need additional lamps, but there's lots of plugs in case you do find you work in a particular area that needs a little additional lighting. But there really should be a lot of ample options to light. I would only add that with what Kathy mentioned, those areas where you have the option, or the Oaks have the option about with the ceiling fans. And again, I'm not familiar enough with the architectural detail to say, how this is working at Trillium. But in those areas, whenever we do have those options, it's where a light would be otherwise. So whether it's, I guess one thing is it does push that down off the ceiling a little bit, but there would be a light option there either way.
Other questions, comments for either current Oaks residents or Stefan or Vassar?
I have another question if nobody else is ready.
Please.
I'm not quite clear on the windows. Do you crank them and they come in? The configuration of them is a little confusing to me.
Yeah, this will be a great one to watch the video link that I believe Jennifer is going to be forwarding along to everyone. But what the way to think about it is they're very similar to a door with a lever handle, and they operate in different 90-degree operations. And so typically the handle is down when they're closed, and then
Jue perra. Ay, la puta madre.
Ah, no mames. Está bien, señor.
No se me preocupe, manito. Ay, con permisito, jeje. Ay, si me pueden traer.
There we go.
XT.
I think we were Zoom bombed.
Yeah.
Yeah.
Uf, me estoy mojando.
Claro, pásele. Ay, haga.
Can we get rid of
Tío,
it?
señor.
Muchas gracias, manito. Dios lo bendiga y me lo cuide. A la verga, porque no entra esta mamada y jue perra. Ay, la puta.
There we go. Okay, so what I was saying is, when you have the handle kind of in standard close mode, it's going to be just pointing down. And then you can take the handle and you're going to turn it 90 degrees and it'll be now kind of parallel with the ground. And that will allow you to just open the window in. And then you can close it and go and close it back again. Or you can take the handle and move it fully 180 degrees. So it's still straight up and down, but now it's pointing to the ceiling. And that'll allow the window to tilt in, the entire window to tilt in towards you. So they're called tilt turn for that reason. I don't know if that's helpful, and it's hard maybe without a working example, but that's how they work.
Are there screens?
Yes, and the screen is on the outside. And so as you're kind of tilting in or opening in, you'll be able to see that screen on the outside of the window. And again, the beauty is if it's operational window, when you open in, you can just clean the window. You don't have to take off your screens to do anything like that. And you don't have to wait for someone to come. If you felt able and were something you wanted to do, you could just clean that window yourself, because there's constantly different air debris, pollen, things like that in our region that dirty windows. So it's kind of a handy component.
Are the screens removable?
Yes, the screen should be removable. And I'd have to check and see, what screen systems you have and how they're removed. But usually there's little tabs that are accessible from the inside that would allow you to kind of, pull the screen out and back into the space.
It makes a difference in the wintertime if you can take them off, because it allows so much more light in your house.
Yeah.
We have that kind of screen, and we do remove them in the winter because it makes a big difference.
I think what you'll find with the Trillium units, because they have those high clear story windows, that you're going to have a tremendous amount of light, much more than you'd see in a typical home of natural daylighting. So those homes in particular have a lot of natural daylighting, just so you know, but that could be helpful too.
Other questions, please don't
I
be.
think Cindy is trying there.
Yeah, there you go.
There we go. Okay, I've actually lived in a condominium in Portland that had that type of window, which I really liked. It's just that at least the ones in this condominium were pretty heavy. Is that an issue? And then other people in the building said that they needed replacing more often. I just wondered about that.
We've found that they, I guess I'll address your questions in reverse.
Okay.
And we found that they don't need replacing as often. I've been using the tilt turn windows, and this is our own experience with a manufacturer that we're using on this project. But what we found is they've actually had less issues.
Oh, okay.
That said, they tend to have, they really work well with this 90-degree operation where you have the handle, you turn the handle to 90 or the 180. If you kind of turn it in between and then pull, you can sometimes dislodge it, and then it needs it needs someone to come in and help you reset the window. That happens, that can be more common as people are kind of getting used to their windows. But what we found is the overall system is both much more durable and much more replaceable and repairable. So that, if it were to break for some reason, and we have had birds fly into windows, things have happened over the years. And the way the windows are manufactured is we can replace glass pretty easily. We can replace just the frame pretty easily. We haven't had the structure frame be a problem yet, but the way we design and build the buildings, we have full access. We have to, one side or the other remove trim. But other than that, we could actually even replace the full frame of the windows because they're of the way that they're installed. It's much easier to replace than a standard, what we'd call flange or double hung window. They are heavy. And so I would say that that is true. Of course, when they're heavy, it's a little easier to pull in than to do the tilt because tilt does require some pushing back. I think it just takes a little bit of getting used to. And, I would be curious if there's anyone here has any feedback from their own units. But, they're a little bit lighter. We did use unplasticized polyvinyl chloride. The Germans again invented that to be a more durable PVC window. It's both more UV durable, but lower in the toxics in the manufacturer. It's recyclable and repairable. There's a lot of advantages to it. It's also lighter than if it were to be wood, aluminum, or fiberglass. And so that it does help. But anyway, just wanted to add that.
Thanks.
I can comment on the windows too. In my opinion, the windows are fantastic. I love them. There's a little bit of a learning curve your first few days with the way the handle works. And like Stefan says, we exactly had that problem. I was like at a 45-degree angle. It just would not close anymore. And of course, Roseville was good about sending an operations person out and fixing it right away. And after that, I learned never do that again. And in terms of them being heavy, they are heavy, but they're on a hinge. So, it's not like it's ever a problem. You just get the sense that these are substantial windows because they're triple paned and they are heavy, but it's not a problem at all. And the only problem that we've experienced is that the middle pane will get condensation all the time. And then it goes away after it warms up a little bit. And I don't know if there's a fix for that or not.
I'd be interested to follow up on that one for sure.
Other questions, comments?
Which direction do the buildings face?
Good question. They have different orientations. And so they're really meant to do both, have a facade to the neighborhood and a facade to the outer neighborhood, I should say, and a facade to the inner community, so to speak. And so, it's a pretty terrible answer to say all directions. But I would say that there is some intentionality to that, to both, have a nice front door, so to speak, to the neighborhood, and also kind of a similar feel for the community side. From a primary glazing standpoint, we have a couple of the units do face directly due south, and some other units face more directly east, and they each have either the east-west or south-north kind of major glazing window sides. And yes, and we have adjusted the design slightly to basically accommodate the overall energy model and everything, to accommodate for different solar aspects for those buildings and shading options for the buildings.
And from a completely non-technical, non-geeky perspective, every building has got a really cool front porch and a really great back patio with a lot of green space around it. That's one of my big deals, is that you be able to connect to your neighbors, to the outdoors, to be able to sit outside with a cup of coffee or a glass of wine. So whichever direction you feel like being, there's just a lot of opportunity for that.
Thank you.
Any other questions or comments? We're just about at our time, but I know we can go a few minutes over if anyone had anything specific. I'm not seeing anyone raise their hand or unmute themselves. So just a recap. Again, my name is Jennifer Wardell. I'm the Director of Marketing Communications. I will be sending out follow-up information to this group later this afternoon. That will include the floor plans to the townhomes. If you're interested in a conversation about that, you can feel free to reach out to me, and I'll put you in touch with our sales counselor. If you have any other questions about Rose Villa in general, I also encourage you to reach out. I will send the video. I've learned from an attendee on this call that I needed a Zoom audio plugin that I did not have installed in my computer. So I could hear the video and enjoy it, but none of you can. And I've probably seen it a dozen times. So I will send that out to you. We will also have this meeting recorded. So that will come to you as well. So if you wanted to go back and listen to anything, see the Zoom bomb in action, you can feel free to do so. And it's just been a pleasure that you've joined us today. I really appreciate everyone's time and interest. And I want to thank Stefan and Vassar for your time and your expertise and your comments for the group. So,
yeah, I'll add my thank you. And I also say that we're now building quite a big group of super, I'm just going to use the word geeky engineer math people who live here. And we love them. People who actually understand everything that Stefan talked about. I just can't even believe it. So I appreciate that level of expertise. It's super cool for me to hear this every time I learn something new. So I appreciate you guys showing up.
Great.
Thank you.
You all. I really appreciate
thanks, everybody.
it. Thank you. Take care.